the link and he's complete.
Okay, good morning, good afternoon, and good night, depending on wherever you are, and welcome to these talks that are sponsored by the Irani Center for Energy Solution from the University of Oklahoma. Today we have a very interesting topic. We're going to talk about geothermal energy. We have with us Dr. Saeed Salehi, who's the expert in the topic at the University of Oklahoma, and we have also with us Camila Castillo, which she's one of the grad students from Dr. Salehi. With us also, of course, as usual, Carlos Molinares and Roderick Perez, and myself, Luis Rodriguez. So with that said, let's talk about geothermal energy. Personally, I have to admit I'm absolutely ignorant in the terms of or in the science of geothermal energy. So, Dr. Salehi, what do you say, or how do you start explaining to a person like me what your topic is, your expertise?
Sure. So good morning, good day, everybody, where you are. It's very interesting discussions on geothermal energy. So if you want to understand geothermal, let's just split the word. Geo plus thermal. So so geo means related to earth, and thermal means the thermal power related to earth. So basically, this is a natural energy that is available everywhere. It's available 24/7, and it's non-depletable. So basically, where you are, depending, regardless of your location, if you dig a hole at your location, you can imagine you are going down and the temperature is increasing. And this is natural because of the Earth's mantle and the core, which is very hot, and then this is keeping the underground very hot. So if you go several kilometers, you can reach out to temperatures of even 100 C, 150 C, depending on where you are. But it's the geothermal energy is very diverse. So people just use maybe one expression of geothermal, but if you think of different diversities of this energy, it can be from very shallow to very deep. So for instance, if you look at the pictures that we have in this slide, it's maybe small, but if you just focus on the left side, you can see a very small, basically borehole. This is a heat pump type geothermal. So the concept is, if you go 10, 15, 20 feet underground, you have a constant temperature of 60, 70 F. So what does it mean? So it means if your temperature at surface is freezing, for instance, it's snowing, it's freezing. If you're able to find a way to circulate that cold fluid from the surface to underground, to 10 feet, 20 feet, you can heat that fluid up to 60 degree Fahrenheit, and then get it back to surface, and then extract the heat. So you can basically increase your temperature from sub-zero to 60 F. So, and this is very applicable. This technology has been used for several decades. It's very efficient, very decarbonized way of heating or cooling your building. If you move to the right on the same figure, you can see there are deeper resources. For instance, hydrothermal resources. So places like Hawaii, or Colombia, or Indonesia, or Philippines. There are volcanoes active. You can drill through the formations, and then you can basically get to temperatures of 200 C, 300 C, and then basically bring that steam, or let's say that energy to surface, use the steam to rotate turbine, and then generate electricity from it.
That's amazing, Dr. Saeed,
Yeah.
Dr. Salehi. One of the things that you just mentioned, that it's something that blows my mind, because I grew up with the idea that the only source for geothermal energy are volcanoes or areas where there are volcanic activity. So what you're saying is that's a myth.
Yeah, exactly. So that's why I'm saying, people when think of geothermal, they think of volcanoes or specific examples. The geothermal is very diverse. It can be from very shallow to very deep, and it can have different type of applications. In fact, people who are working on the shallow geothermal may not necessarily be an expert on the deep ones, or people who are expert on deep geothermal not necessarily going to be expert on the shallow one. So even though it's all the same process of extracting heat from underground, the way you do it, the design, the well applications, the type of fluids you are using, the type of production, the surface facilities, there are different ways that you do it. So that's why it's important that the differences. So for instance, we have also very deep geothermal applications. They call enhanced geothermal system. So enhanced geothermal system basically is a commercial way of producing electricity, and it's very similar to way we frack the oil and gas wells. So this is applicable in places like that have hot formations, like granite, or formations that are have very high temperature. So basically, use two wells. The simplest way is using two wells: one injection and one production. So in the injection well, you basically go pump water, you frack, and then from the producing well, you produce this hot fluid, and then take it back to surface, and then use that water to generate electricity. So basically, there are two classifications of geothermal when the people you sort of discuss it. It's one is direct use application. So direct use means you are not generating electricity. You are just either heating up or cooling, the fluid, and then using that. So it's like some of these homes that are heated by this fluid system. So you don't necessarily using electricity to do that. It's just the fluid comes back to your home. You extract the heat, you warm it up, and you do the reverse thing in the summertime. The other way, or the other classification, is generate electricity. For generating electricity, you need to have a specific temperature requirement. For instance, it should be research, or let's say applications show that it should be above 100 C. So for the formations that are not that hot, are they under 100 C? It's going to be difficult for generating electricity. So if you look at, for instance, the graph on the right side, it's a very informative graph that shows so what temperature is useful for what. And you can see, for instance, for very low temperature, 100 F, for instance, okay, very nice direct use applications like fish farming, or building heating and cooling, or um, food processing, for instance. They don't need to have that very high temperature. And as you're going up, this is very interesting, showing what type of power plants, for instance, you're needing, and at what specific temperature. And then the top tier ones, everything that goes above basically 260 F that you see, these are basically for producing or generating electricity. But keep in mind, geothermal is not just electricity. It's energy that you can use in diverse places, heating and cooling, to food processing, fish farms, pools, hot tubs, everything else. You could use it and tap it for different things. So go to next, please. So if you look at this slide, this is basically for the map of the US. Now there's also a world heat map that we can go with, but this is the basically heat map of the US. So you can see the map says temperatures at 10 kilometers, right? So there are some very hot spots on the Western hemispheres, like, parts of California, Nevada, New Mexico. So these are basically good potentials for generating electricity. So that's why you can see that in the US, most of the geothermal power plants are on the Western hemispheres. And you can see that's the temperature at depths of 10 kilometers. So that's an average sort of temperature. So means if you drill a wellbore to that depth, to around that depth, you can tap into this temperature. However, it doesn't mean that you cannot generate electricity from the other places. It just needs to go deeper. For instance, if you look at the place that we are in Oklahoma, at 10 kilometer, the temperature is not that hot, but it's still, you get easily something between 100 to 130 C. Now, if you go deeper in Oklahoma, so instead of 10 kilometer, you go to 15 kilometer, you can reach out to that temperature. So the difference here is that, on the Western hemisphere, you probably have a better temperature or higher temperature at shallower depths. But if you go to the Eastern hemisphere, it's just, you're going to have to go deeper. And regardless, it's your cost is changing here. So one of the barriers, for this geothermal application is actually the high upfront cost. And for us in the oil and gas industry, we have dealt with, high temperature drilling in the past, and we know there are a lot of problems like, failure of the tools, mud logging units, MWD units, drilling fluids, cementing. When it goes to very high temperature, it's hard to control it. A lot of time fails. You need to spend a lot of capital to have a better tools. So this is sort of the major problem, or let's say the major barrier.
That was something that I was thinking, Professor Salehi, that there is a lot of the oil and gas industry in general can contribute to the risk that kind of risks that you are mentioned. Probably you can explain better in the next slide, please, because how the oil and gas can contribute to the risk that factors.
Sure. So so this is sort of showing the slide, that what's the difference between the risks in the geothermal operation, and you can see that the risk in the geothermal is very high at the beginning. So because the drilling cost is high, the risks are higher. Unlike oil and gas wells, that if you are having a field that and then you have drilled a lot of wells in there, the risk goes lower as you're drilling more. But in the geothermal, it's not necessarily true because it's high temperature, it's always high risk. So that's one of the hardship that we are dealing. But as Carlos mentioned, there are things we can contribute, as oil and gas industry people to geothermal scaling, or let's say development, and because of the skilled workforce we have, because we can easily learn the concepts. This is again drilling. Whoever has worked in drilling can understand the beat and rotating of the pipe and mud and everything. And geothermal is not far from it. It's just maybe harder rock, granite, but it's still same concept. You're using drilling rigs, so it's the skills are very transferable. So you can go to next slide. I can explain this better. So this is what I prepared a couple of months ago when I presented this in the SPE. So so many people are curious to know how can they transition to geothermal. So what are things are same, what are things are different. So as I mentioned earlier, there are a lot of, so if you look at these two circles, or let's say two areas, you can see there is a lot of overlap. For instance, the overall rigs is functioning the same. The method of drilling, again, we are using PDC beads recently, tri-conduits, we try to use some high temperature logging. We do same casings, but for high temperature. We do cementing, but adding a lot of additives for the high temperature. We try to use high temperature fluids. Project management are very similar. Stimulations are very similar. From safety perspective, the risks are higher, but it's a lot of similarities. Now, it's not 100% the same. So you have to keep in mind the permitting process, for instance, for geothermal is completely different. So you have to, because now you are dealing with not a commodity as oil or gas. This is energy, or let's say heat. So the permitting process is different. Right now, the permitting process is very long in the US. So that's one of the barriers also. The regulatory environment is different. We don't have much regulations, right now, but there is possible that's going to be added. And most importantly, the financing is different, because the way we are financing in the oil and gas industry is we sell the commodity, to the consumers. But in the geothermal, you have other middlemen here. You have the utility companies that have to buy the power from you and then take it to consumers. So there is, those differences. But overall, from technical perspective, it's very similar to so right now, the geothermal industry in the US, or the people working in the geothermal industry in the US, there are more than 90% of them, they have the oil and gas background. So those are the people working in the oil industry. Now they, move to the geothermal, and, they are very successful and, making a great progress. So move to the next slide, please. So we are having a lot of activities in the University of Oklahoma in terms of, geothermal. We have basically a Geothermal program that we offer a degree as geothermal. We offer several courses for geothermal. We also doing a lot of research projects on geothermal in terms of, looking at different aspects of geothermal energy development, here. So if anybody interested later on to maybe get a degree in geothermal energy, you can contact me and we can discuss it, but we have that option also. So one other activity we have been doing is competing in the collegiate competition for geothermal energy, and recently we got the first place. I have two of the team members here, so I want them to talk about this. So Cesar and Camila, can you please explain about this project?
Yeah, sure, Dr. Salehi. So, good afternoon, everyone. I'm Camila Castillo. I'm a master's student. I work with Dr. Salehi. So, for the Department of Energy, organize the Geothermal College Competition, and I was with Cesar. We were in the team for this year. So basically, we have a team that is that has different backgrounds. So that was very beneficial for us because we have like the opportunity to cover different areas. As Dr. Salehi was mentioning, you have to take into account the permitting and also the risk. And not only that, also we wanted to do something different. So we also work on a curriculum and also on a stakeholder engagement strategy to be able to teach about what is geothermal energy, its importance, because we are talking that, Dr. Salehi mentioned, one of the applications for geothermal energy can be direct use for heating and cooling buildings. So the goal of our project, we work with targeting the Shawnee community. So maybe Cesar can help me to explain more about this.
Okay, can you hear me?
Yes, we can.
Can you?
Yes, we do.
Okay, okay, excellent. No, the idea is that we look into for this project, as Camila mentioned, we were looking for using existing infrastructure that was nearby public schools to use geothermal energy to harvest the heat and heat and cool those buildings. So we found a place in Shawnee, Oklahoma. We identified 6 different wells that are inactive and are near to 3 different public schools facilities. So we did all the engineering process, petrophysics, reservoir modeling, enthalpy production forecast, you know.
Oh, it seems that we lost Cesar.
Okay.
But we were talking about the project about heating these schools using in existing wells or as infrastructure that was already in place. Is that right, Camila?
Right. So as Cesar was mentioning, we work on the simulation. We also cover the risk, and also we have. Okay, Cesar is back.
Yeah, I'm sorry, this the application is taking me out a lot of times. So yeah, finally, as in few words, okay, we did all the engineering process similarly as we do a prospect in an oil and gas operation, and we and we
And we also want to.
So I can add few stuff if you guys let me about this this idea of the project. So both what the students did and what we have been sort of funded by the U.S. Department of Energy is to convert the oil and gas wells into geothermal.
Mm-hmm.
So the idea is basically, you produce oil and gas for several decades, and then they start to deplete, right? And then instead of plug and abandon those wells, you can find methods or ways to basically make them a geothermal. So this is sort of the idea we are working on. The project site is in Oklahoma, and there are 4 wells that we are trying to convert them. The wells are drilled in 1985, 2002, 2003, and 2005. And they are actually in the 1 mile distance of 2 schools. And what we are trying to do is retrofit these wells and then use the energy to heat and cool the school buildings. So instead of them using electricity, they're going to have access to energy, 24/7 energy from these wells. And then it's going to be a huge saving for these schools. And not only that, there are about millions of these wells right now in the US. And if you think of the overall globe, it's probably another, million wells or a couple of 100,000 wells. And then it's going to be a saving for the operators. It's going to be the saving for the people, and it's also a good source of renewable energy, and we can also use the oil and gas people, skill to work on this type of projects. So
That's amazing. So what you're saying is that we're recycling wells, essentially. Instead of plugging the wells, you're recycling the wells. And we have millions of wells drilled in the United States. How come we're not doing this more often or in more places, Dr. Salehi?
The idea has been around in terms of, people have been talking about this, that, why don't we use oil and gas wells for geothermal? But the issue has always been a demonstration. So it's like, first time somebody's building an electrical car, people have been thinking about electrical car, but it was a Tesla that made the idea commercialized, that you actually, the car can have a battery that is working, So the same thing is here. So I think the demonstration always been an issue, that, okay, how come a well that's producing oil and gas now suddenly, is going to produce geothermal energy? So there are things that we have to do. There are not that every well can be qualified for this. Wellbore integrity condition is a big thing. And second thing is, you may have a situation that you produce oil and electricity at the same time. So these are the scenarios that's going to happen. That you're going to have wells in the future that produce oil and also produce electricity at the same time. So this is a scenario that's going to happen.
That's great. So what you're saying is this is a growth industry, just like what happened with Tesla, let's say 25 years ago, where everybody was laughing at those electric cars, and now everybody wants to buy one. So what you're saying is we are essentially in the same stage. We're just beginning to grow this industry, and the potential is huge, and in the future is essentially the sky is the limit.
I think it has a, yeah, go ahead, please.
No, I think, guys, you brought a video, so I think it's a good time, Luis, for you project out to show more details about the project. You don't, yeah. Please talk about it.
Yeah, maybe let's look at the video. It shows the potential site and the wells, and then I can discuss after the video some more details about it. So this is basically about 30 miles from the university. The town is a small town, but it has a lot of oil and gas activities. So we have identified these 4 wells. They are in very close distance from the schools that I mentioned, and we're trying to sort of demonstrate this technology that's going to work on these wells. So you can see in this video, after this farm, these are the schools, So if you look at the whole U.S., there are a lot of these wells. There are 100,000 of these wells, and a lot of these wells are in close proximity of end user. So schools, farms, churches, buildings, So if you're able to identify those wells and then you try to use them in the right way, there's a lot of potential energy, not only switch to renewable, but also we can be a leader in the renewable energy. I mean, the oil and gas industry can be the leader. It's not just solar and wind that people are talking about. It's the geothermal energy from the oil and gas wells. And the beauty is, yes, go ahead, please.
Dr. Salehi, nice to meet you. I'm Roderick Perez. I'm also a OU student, former. And talking about the percentage, because it looks so good to be true, as Luis Carlos was talking about. But I mean, I'm a geophysicist by profession. But what is the percentage of the wells that, beside that, the bottom hole temperature is good enough or enough to produce energy? In terms of the conditions, in terms of the well's construction, I mean, are all the wells suitable to be transformed into a geothermal well? What can you tell us about that?
So I think there are a lot of learnings we're going to have from this project, but there are a couple of things that we are thinking to be true for this type of applications. Is number one, we think that the well that we are going to use for such applications should have a good wellbore integrity in terms of the casing and cementing. And the reason is, unlike oil and gas that maybe you are just producing and then you're abandoning, plug and abandoning. If you want to keep this type of project active for many years, and because you are circulating hot water through these casings, there's going to be a lot of these thermal loads on the casing and the cement. So you need to make sure these are a good casing and cement or good type of wells that you choose for this type of application. So again, not every old well can be used for this application, but there is likelihood that a good percentage can be used. So we did estimate that if we use only 5% of the wells in the US, of the old wells, recycle only 5%, that's going to, provide energy for a city like New York for 50 years. So So you can see, the scale is huge. Only a small percentage.
Okay, team, we have a question from one of our viewers, Diana Acero. She's asking probably Camila directly, what is the benefit for the students and the faculty to participate in this type of competitions? And I'm going to go even further than Diana. I'm going to ask you, why do you choose this major in particular? Why did you choose geothermal energy for your major, for your specialization in the future?
Okay, so today we are talking about energy transition and what is like the importance of move from the oil and gas, but specific from the coal, and start just thinking about other renewable sources. So as we were talking in this session, geothermal energy has like a lot of pros and also has a lot of potential, not only here in Oklahoma and not only here in the United States. It has a lot of potential in all the work. So my background is in chemistry, but I'm really interested on learn more about how we can apply all our own knowledge in geothermal. And this is a really interesting topic because not only there is not like a specific background that you have to have for geothermal energy. So you can be petroleum engineering, you can be also mechanical engineering, you can be a chemist or chemical engineering, because there are a lot of areas that a geothermal energy project needs to cover. That there are space for different backgrounds. And talking about Diana's question, for me, I have the opportunity to learn a lot. So through the competition, we have different talks that the Department of Energy offer. So we learn about how we can write a prospect of the project. So we learn about the permitting that we have to consider. Also, we learn about the risk. We include some simulations. So one of my teammates were focused on how we can simulate the reservoir, how we can see if it's feasible to use the wells that we selected for the project. Also, we focus on how we can like transmit the knowledge that we are just acquired for the community. So we also create like a curriculum for the community. We have some meetings with the principal and the superintendent of Shawnee School just to discuss how we can like teach to the high school students and just encourage them to have like the interest in research more about, in this case, geothermal energy, but not only geothermal, about renewable energy. And because, yeah, so it was very beneficial for us. We learned a lot. And also for the geothermal collegiate competition, we have the opportunity to do, we are organizing a stakeholder event that will be at the University of Oklahoma in September. And in that event, the event is open to the whole community, not only for OU community. You are invited to participate. And in that event, we will like to share our experience, not only in the competition, we will also have guest speakers. And the idea is to try to interact with the community and share some of the knowledge we just acquired working with Dr. Salehi and working in the competition. So yeah, it's very beneficial for us. And it was a really good opportunity that I'm really proud to be part of this team and to be part of Dr. Salehi's loop.
Well, Camila, again, I would like to say that this is amazing, and also for our community that is listening, I just want to highlight that the University of Oklahoma, especially the Department of Geology and Geophysics, and also the petroleum engineer, has a record, an impressive record of participation, and to be one of the best universities in the US, worldwide, especially in competitions like the Imperial Barrel Award that myself and I think Carlos had the opportunity to participate, especially with the assistance of Dr. Slat, that right now is not with us, and also the petroleum engineer in the Petro Bowl with Dr. Sondegar and Dr. Wright during the so many years has been winning and have one of the leaders. And it made me feel so proud that also right now, first, also for the community, and tell me if I'm right or wrong, but for me, it's very impressive that, especially that this kind of competition is supported by organizations that in the name, in the label, have petroleum. That is, for example, the Society of Petroleum Engineers. And I think it is very also well mentioned that it is a change in the paradigms of that not only petroleum is only oil and gas. I mean, it's also very nice that we need to highlight that this is also, as for the future people that is coming, to study petroleum engineering not only means drill oil and gas. I mean, we are part of a large amount of ways that we can generate energy, and this is one of those. And also, Camila and I think Cesar, also I would like to highlight that being international students at the university also make us very, very proud, because in my case, when I participated in the Imperial Barrel, we were 4 Colombians and 1 Venezuelan. 4 Venezuelans and 1 Colombian, and we won the international. And I mean, it's also very nice, and congratulations, because you're putting the names, not only Colombia, the Latin American, and all the international students very high, and congratulations. And well, before that, I will going to read one of the questions from Luis that is, was the well a horizontal well? What is the closed loop system? Can you tell us about that?
Yeah.
I'm assuming they're talking about the total experience in the project.
Yeah, the wells in the competition or the project, yeah. Well,
so none of these wells, I can maybe answer this question. None of these wells were horizontal. They were vertical, and the goal, I think, was that we're going to look at recycling the wells that are close to depletion. However, it doesn't rule out the horizontal wells for such application, because again, the requirement is you have a hot well, or you have a temperature that's good enough for for the direct use application. And then it wasn't also a closed loop; it was an open loop. So basically, it's injecting and then extracting heat from the other well. The concept can be also be applied for a closed loop system, but again, the closed loop, you have to you are not recycling closed loop from industry, so you have to drill them. So basically, it's going to be additional drilling costs.
Well, and thank you for Susan also for another comment saying that this is very impressive. I'm also very, very impressed. I mean, this is amazing. I never thought that you could actually end up recycling essentially all of the wells in the United States if the technology gets to that point. But I have one final question, which is probably what Luis was meaning when is there any advantage between having a vertical well versus a horizontal well for this kind of applications?
So, maybe the most important thing is, in terms of the feasibility, is the size of the wellbore, because you can produce, in a larger surface area, right? So if you be able to have wells that have a good temperature, and you have a production casing size of good sizing, maybe 958 or 12 quarter, or or at minimum like a 7.5 inch, then that would be meaning that you're going to have a larger surface area for production. So at one specific time, you're going to produce more heat. So in terms of the horizontal wellbores, maybe one advantage is that because you are going to have a larger surface area as for oil and gas production, you're probably going to have a larger surface area for heat production too. So that would be an advantage you can leverage for this type of application. But again, the horizontal wellbores are quite new, and there are not many of those depleted. So maybe this can be a concept we come back and look in 10 or 20 years, to recycle those.
Well, thank you, Dr. Salehi. And with that, we thank you for your participation and thank you for coming to this forum and talk to us about the geothermal energy. Like I said, we're very impressed with this information. We didn't know that the science and the technology is this far advanced. And we are happy to see that this is a potential industry for growth and for future development. So thank you for coming, and thank you for Camila too for coming and for helping us with this forum.
Yeah, I thank all the panelists and everybody was listening. It's if anybody wants more information or discussion, you can contact me directly, and we can have a more discussion.
There is one last question from Luis also. He's asking about the operator where he gave the well to OU to do the test, or what was the ownership of the wells? Was the ownership transferred to the high school, to the operation, to who?
So the owners are actually like you guys are alumni of the OU. So so they were very excited about this, and they didn't want to do this for any financial benefits. It was just a donation, and they liked to help the OU, and they liked the project. So that's why they work with us. And then we're gonna have access to the wells for doing the operation, and they're gonna help us in terms of the operation. So it's sort of a very generous donation.
Mm-hmm. It seems that we have a lot of questions regarding ownership. Mr. Rogue here is asking whether the well in the future is going to be plugged, and who assumes the plug liability for those wells.
So these are very good questions and good areas. As I mentioned at the beginning, the regulatory environment for geothermal is not mature yet. So there are many states that they don't even have any regulations that, who actually is going to be liable for that. Who, if something happens, then what's going to happen? So these are the type of things I think is going to develop in the next coming years or decades. We have to think of this as the earliest stage of oil and gas exploration. So there are a lot of rules and, regulations going to come out. And I think a lot of states that we have talked to, they are very open to this idea, so welcoming to this idea. So I think it's going to be more positive, interactions with them, and hopefully, it's going to be good for our industry as well.
I agree. Thank you, Dr. Salehi, and thank you to Camila Castillo too for coming, and hope to see you guys in the future again in these forums. Thank you for your participation.
Thank you so much.
Yeah,
Thanks,
thank you so much.
It was good talk to everybody.
Thank you.
Bye.